joining us for this webinar today. This is Sanu here from Javelin, of course, and we're going to go through some SOLIDWORKS PCB today as we go along. So today, what we're going to cover is, I'll keep the slides to a minimum here. Just an introduction to Javelin and any updates that we have. What SOLIDWORKS PCB is all about, the current PCB landscape, and why SOLIDWORKS PCB is is in play, and what we're talking about today, and then demonstration and next steps and any Q&A that we have. So just a quick update on Javelin. We are growing quite a bit, of course, and we are, I believe last count was 94, 95. So 90 plus people, hundreds of certifications. What does that mean to you? That we are there across the country. We are Canadian, of course, only SOLIDWORKS and SOLIDWORKS other products, resellers, value added, of course. So we have support, training, implementation, all of it across the country. So our support hours go from Dartmouth to BC. So you can start early in the morning and end late in the night, and we'll be there to listen to you if you need help. Our whole strategy behind how we work is people, technology, process, and manufacturing. So we understand that it's a whole cycle. We help with training, onboarding, ideas and concepts, and that's taking care of the people, because we know and understand that that's the most important thing. Technology is what we're going to talk about today. So take it about mechanical or SOLIDWORKS technology. You're talking about or electrical with SOLIDWORKS electrical or SOLIDWORKS PCB. Process is more than just one thing. PDM, of course, helps in tying everything together in a process. But other things like reviewing your processes today, learning from you, and helping you make that better and streamlined so that you can use all three things to help your manufacturing. And of course, if you're doing some prototyping or just modeling, these days 3D printing is the thing to do, and SOLIDWORKS understands that. Javelin understands that. So Javelin works with Stratasys 3D printing services and machines, so we can help you in that area as well. What's SOLIDWORKS PCB? Two things. Our friends out there who are using Altium, we have something for you as well. SOLIDWORKS PCB by itself is a full-fledged PCB design system, 2D schematics, layout, and even 3D right inside the software itself, and it connects seamlessly with SOLIDWORKS. That's on the SOLIDWORKS PCB side. That's an all-encompassing thing. Now, if you're already using Altium Designer, because SOLIDWORKS PCB is powered by Altium, so SOLIDWORKS and Altium work together to get that going. We have something called a PCB connector, so where you can purchase that and add on to your Altium to be able to connect it to SOLIDWORKS as we are seeing today. So the interface is pretty much the same on the SOLIDWORKS side of it. On the Altium side of it, you just have a very similar interface again, and we'll take a look at that. But essentially what we're talking about here today is to bring together both mechanical, electrical design systems in more than one way. So today, in the landscape of current PCB design, you're talking about, either DXF or IDX or, any other import-export format. You would say, maybe step file here, there. If you're a SOLIDWORKS user, you might use CircuitWorks at times. But it is about back and forth. There is no real-time updates and real, collaboration. What we are proposing here is to change all that, where we're talking about adding nothing in for export and import, rather have you seamlessly work between your design, your board outline, your placement of parts, and how that fits into your mechanical system. How does that fit into a box you're creating, or the next Nest controller? And this comes from multiple things. Of course, Internet of Things is one thing that has sparked this industry to move forward into both bringing everything together. Space is always a constraint today. So what are we going to take a look at with SOLIDWORKS PCB? Of course, we're going to talk about schematic capture. Very great tool. You can do colors and hierarchical design, so that you can put your traditional schematic away and do something that is easier to understand and manage. Your traditional PCB, of course, layout. You can do multiple layers, as many as you want, and have simulation done on it as well, optimization there. You can do 3D visualization inside SOLIDWORKS PCB as well. So that starts off with SOLIDWORKS PCB inside SOLIDWORKS itself, and then in PCB itself, and you can take it to the visualization in 3D where you're talking about mechanical collaboration. And that is very seamless, and we'll see that today. Of course, you can then take it a step further if you would like in the same SOLIDWORKS ecosystem where you're talking about electrical integration, where SOLIDWORKS electrical can be used, PCBs can be imported for just their pinouts or anything like that, and utilize that to create cables and wires and harnesses and document that perfectly. And of course, when you've done all that, or in the middle, you can use SOLIDWORKS ecosystem, visualize or just rendering to make photorealistic things that can be used for marketing or just for how realistic it looks for troubleshooting or anything like that. That's what SOLIDWORKS PCB brings to the table. What does the design workflow look like for us today? We're going to take a look at collaboration. We're going to take a look at schematic capture. We're going to take a look at PCB layout and some deliverables as well. So we have, about 20 minutes to go through all that. So we'll get right into it. We'll start with SOLIDWORKS here. So what I have here is, a part. It is, if you're an Altium user, you've seen it. Altium used to have this, writer for that, and it's called DT01. And we're going to take our PCB, which is, there's a mock model here for the PCB. It's a flat PCB, and inside our PCB design, which is the SOLIDWORKS PCB interface here, I'm going to open up the schematic where we have some parts already placed, and our PCB, which is currently empty. So we don't have anything here. We are going to start with, on the SOLIDWORKS side of it, saying, hey, what is the shape of my PCB? Can my PCB, which is essentially, a rectangle or a square here, fit into this? I would say no, that's not going to happen. You can be, what we'll take a look at is, okay, let's just go to the assembly, insert components, and bring that in. So we've brought that in. Maybe we'll do some mates here to align that correctly. This PCB, of course, is too big. We are not going to be able to use this to fit this in. So what do we do? Now, traditionally, you would go, make something and send it out as DXF, so on and so forth, and continue doing that. What we're going to do today here is just edit the sketch and select the chain, delete that, and I have a board profile here that I'm just going to select and convert to the sketch and finish that sketch. So now you can see that, hey, my board now fits in my device correctly. You'll see, of course, the PCB design here is updated on that. So let's go into that, and that's my part. And you have a nice dialogue here where you can have the interaction with your SOLIDWORKS PCB, inside SOLIDWORKS and your PCB designer. So the mechanical designer goes and pushes thing, updated board outline. And we can post that in, and SOLIDWORKS will take that update, and it will push that in. So as I'm looking at it, my SOLIDWORKS PCB tells me, hey, there's an update here, so let's view the changes. You can click on it, and it has a nice animation saying, hey, that's what it looks like right now. That makes sense, so I'll accept that. And it, instead of manually doing this inside the PCB designer for board layout, you can set this up so it's done easily inside of SOLIDWORKS and pushed in. Now, of course, I have the schematics, so let's pull some of the schematic stuff in. It is linked completely, so if you're using a solution that is not linked and you have to do import and export there, those changes happen as well. So these are my schematic changes that I have, and I'm going to execute those. it's like an ECO service, so you can keep track of what it is. And then we are able to place these. Now, of course, you can use spacebar to turn these around and place that. It's placing it on the top layer right now. If you have anything that needs to, flip or do anything like that, you can, place it on a different layer. You can place on the back plane, of course, or the second layer, and put that in as well. And if there's any collision or anything like that, it is a live message saying, okay, that's in red. It says, okay, there's going to be a collision, and of course we don't want that, so we'll place it in a right place there. Let's rotate that in. Maybe we want to place it here, and let's put that there as well. So now that I've placed it, does my mechanical designer know what the clearances are, what the tolerances are? Not yet, of course. So let's put that across, saying, hey, placed some connectors and devices. So that's sent to our mechanical designer. Let's go back and check what that means. We have an update here that says, hey, there's a few things that my PCB designer has sent across to me. So let's take a look at that. It is all the stuff that we placed. So let's check all of them and accept those changes. So it's going to go and add those changes in for you. It's all updated. The placement is right. What we placed on the back panel, or the second layer there, is there as well. So all of a sudden we have a design that's updated. Now I can, of course, go into my part here and start figuring out, okay, is this clearance correct? Am I going to be able to connect anything? Maybe there's an HDMI connector that is a little too far from the edge there. Maybe I need to get it closer, or maybe my card reader is not accessible. I can do all that and map those changes, essentially creating a great design that is without having to go back and forth and making 1,000 changes. So very quickly we can get that done. So that's your schematic capture, your PCB design and collaboration all in one place. Of course, and that just really brings everything together. I'm not going to make any changes here. I'm going to save this document and close these, maybe close the project. And I'll take you a little forward in the design. We'll save those changes. And you can come to maybe really forward in the design. Let's say I've made a few changes in the design. I've added a few things, and I'm going to show you how you can do some schematics here as well. Library management is pretty easy. You have the libraries on the right-hand side. You can take libraries from the Altium website, initlib files, and add that in. Altium has a robust library system. It also has something called supplier links, so you can have live links between suppliers. But let's take a look at how we do some design here. So I'm going to make some connections. Maybe I'm going to connect that there. Fairly simple, fairly standard way to do things. And same thing here. So let's quickly do the rest. And see if we can add some parts on these connections. So I have a multi-symbol part here. So it's a hex inverter. So I'm gonna place that, and it'll give me the next one to place automatically, where I can go and place these on the line. And if you have any symbols or anything that's left out and not placed, you can place that as well. So if I double click on that, it takes me to my pin configuration where I can say, okay, that pin and maybe that pin I want to place separately. Those are, hidden pins or pins that are not active right now. Maybe I want to flip that and make that connection. I'm going to show that, okay, that's visible and that's my ground. And maybe that's going to be my VCC, so let's connect that. And VCC, so on and so forth. So, very quick and easy to do the design. So if you have multiple parts, I have space for some other parts as well. So for example, I can place this right over there, connect that, and continue my design wherever I'm going to place it. Maybe I want to place it there. Again, maybe I want to flip that to the y-axis and make those connections, or flip that on the x-axis and make the connection, so on and so forth. So you can kind of start adding those things and controlling how you're placing these. And it has other parts that you can place. It will keep giving me the rest of the parts, and I can escape if I want to stop it, and then I can do add more later, so like here or anywhere else. And when you've made those changes, of course, you can start adding labels and information for interconnectivity. Simple things in schematic, you can have buses and power ports and off-page connectors, all the standard stuff that you have, signal harnesses and so on and so forth. I really like the signal harnesses. It keeps your multiple signals can be kept together and managed very easily rather than having multiple connections going across your schematic. You can divide the schematic into multiple pages, use your sheet connectors and to connect them together, so on and so forth, and add notes and so on and so forth. So it's basically a great way to work and manage your schematics, at which point you would go and update your design in your PCB. Let's take a look at how how you do that. So I'm not going to save any changes here, close this project, and take you to another project where I've done some more design, and we'll get right into it. So that's my schematic. I've added a few more things in here, added a couple of more schematics, and taking a look at my PCB. So this is almost getting to the end of my PCB design, where I can add mechanical information and assembly information on the mechanical layers. You can import from DXF if you want to, if you have some things that you want to add notes and drill guides, so on and so forth. So if I wanted to add a drill table, for example, I could very well just click on that, and that has all my drill information, what drills are going to be, the hit counts, and so on and so forth. Makes it very easy to manufacture this manufacturing process. And if there are any schematics that I want to connect here, I can just say, okay, I'm done with my schematics. I want to import all my information from my schematics, and I'll get a list of things that I have. Now you don't have to get all of them. For example, I'll disable everything and maybe just get a couple of things so it can show you that we don't have too many things lying around here that we want to place. Maybe I'll just get the 12-volt ones and execute, and I'll get that in here. It's placed in here where I can then go and start placing this wherever I want to. If I want to flip that again, I can flip that, put on the back layer. Of course, the second layer, the signal layer, I can rotate that. If it's going to be on the top layer itself, I can put that as well. And I have one more that I can place wherever I want to. So let's say it's placing there, and start adding some connections. Now, adding connections is very easy. Of course, you can do auto route if you want to. Auto routes can be done for certain signals or certain classes. I really love the interactive routing because we all know auto routes don't do the exact thing that we want to do all the time. And there are multiple ways to do some interactive routing. So one, of course, is just a normal route where you can go and select what you want to connect, and it will highlight if there's any matching net that is there, so it dims everything else. So if I select that, for example, it'll dim everything else. If I select that, it'll dim everything else, so on and so forth. So, you can make connections between wherever you want to, and again, this is very interactive, so you can start going around, and if you have hug and push or just hug, it'll start matching up to whatever it needs to be. Of course, if you have anything that you want to connect, you can just click on it and it'll start going, and you can have those connections there. If there is a connection that I want to select, I can very easily select the whole thing and delete that if I wanted to. So it's not that you are bound by one connection or the other. Very quickly you can do those connections. Interactive route, of course, is differential pair routing as well as there. So differential pair routing is really great because I can start, if you want to control the distance, you can. If you can reduce you can cycle through what the line, your trace sizes are. So let's say you start with the bigger trace, and then if you want to reduce the trace later on, you can do that. And these are just keyboard shortcuts that you can find. I have, for example, a shortcut that helps me, shortcut window that helps me essentially take a look at where I'm going and what I'm doing on that. And the third type of routing, of course, is the multi-route, where I can select multiple things, and it doesn't need to be a differential pair or anything like that. And this is especially true when we have some constraints on routes, how we go about doing that. We can do that again and cycle through what's, if I want to reduce the size, maybe I want to bring all of that out and then start routing, and then I can start going about that. Now, I don't have to finish the route. I can do one of them and start doing that. And of course, if I just go and say control click, it'll go and finish the route for me. So I don't have to go and always have to route exactly. When I'm close enough, I can do that, or I can just click on it and then control click, and it will go and connect that for me. So I don't have to do end-to-end routing every time. That really makes life easy when you're doing these routes. Of course, making connections yourself is easy as well. But I like this control click a lot. So I know I'm close enough. I don't really need to have to do that, and it will control everything. And you're routed, you're connected, and you can essentially move on. That's a bit for routing that you can do, and of course all this can be exported as a step model or anything like that. So once you have done your design, you have a thorough design rule check section where you can set up what your clearances need to be, and based on nets, classes, so on and so forth, and even what the route widths are. Once you set this up as a standard, it's so easy to make sure that your designs are correct, that you haven't made a mistake. Your boards are better designed for that, for fan out, for differential pairs, or just figuring out, okay, what's the component clearance, how far do you go? And with 3D, you can, because it is using a great 3D engine, you can even define vertical clearances. Even if it's different shapes, it kind of does the 3D engine for you, so you can figure out what the clearances need to be. And at any point, you can run a design rule check, for example, and get results on what are the errors. So of course, I haven't done everything on this design, so it is going to give me a bunch of errors. It's going to run through all the scenarios that we have placed in front of it and tell us, hey, these 100 errors have popped up, 91 rule violations, where some of it is that, hey, the net tolerance is low, maybe silk to board region clearances are not correct. There are some unrouted nets there that you haven't routed. Maybe we want to do a polygon pour on that, so we can connect all the ground nets together, so we get rid of a bunch of errors. And those things are fairly easy to do. And the polygon pour especially, I really like that quite a bit, because I can start doing a polygon pour by just creating a new polygon from my board outline itself. So all my, the board is right here. Instead of having to draw everything, I can do the polygon pour, maybe connect it to a net. So let's say I'm connecting it to my ground net. and whichever layer you want it to be on, and let's say G and D, right? And that will create a polygon which now has based on the board outline. It is, and you can define how the polygons are poured. So if you have multiple polygons, how they are, and so it's taken the board outline. So that's how it's going to pour it, and it is going to help you, figure that out. You can do auto generate, so your pour consistency is maximized, and you can create clearance rules and so on and so forth. And of course, whenever you're done with it, you can click, say, you want a hatch polygon, or you want a solid pour, and so on and so forth, and essentially go and do that, right? So, or you can create your own polygon, of course, if you wanted to, just by using that very quickly and easily. I can expand this, and it can be anything you need to be. Very quickly, again, you can manage all that, and of course, all of this is updated in SOLIDWORKS. You can create bill of materials as outputs and so on and so forth. I haven't completely showed you the output section here, but you can produce Gerbers or drill files and net lists and statuses for that. You can create a pick and place list. Very easy to generate those outputs and work with that. All the libraries can be there together, and settings and so on and so forth. These windows that you're seeing, a few of them are manageable as well. So I can open or close these and so on and so forth. So that brings us to kind of the end of demonstration here. So what we've seen today is 4 things. One is collaboration